elevator acceleration project. But first of all, we're going to look at some theory behind the acceleration of an elevator. So first of all, when you go upwards on an elevator from the bottom floor to the top floor, you feel an initial jump, and that's when the elevator is accelerating to its constant speed. And once it reaches that constant speed, then you're not going to feel heavy anymore, because when you're accelerating, you will feel heavy. Then you're going to feel constant the entire way, and then you're going to slow down at the end. But for this project, we're only going to look at that initial acceleration. Similarly, when you're going down from the top floor to the bottom floor, you're going to initially feel very light, and that's when you're that's when you're accelerating but downward. Then you're going to hit your constant velocity for a while, you're going to feel normal, and then you're going to start to then slow down again then you'll hit the bottom floor and you'll stop. So when we do this, first of all, we're going to state our hypotheses surrounding our project, first of all, and then we're going to show you our calculations behind the project.
To do the experiment, we have a couple hypotheses. First, when the elevator is going down, my weight will go down initially and we'll have a negative acceleration. Second, when the elevator is going up, my weight will go up initially and we'll have a positive acceleration.
Yeah, just click the button. Oh, I got it.
Alright.
Oh, dang. Thing just starts. Oh, Jesus.
Are we down already? I didn't time that. Damn it.
Yeah, it's okay. Jesus Christ, I went up to 2 and then.
What?
We're going back up?
Yeah. Are you doing the same video?
Yeah. Jesus, I'm fat.
We have our initial equation, which is net force equals mass times acceleration. And when we simplify this looks to force final minus force initial equals mass in kilograms times acceleration in meters per second squared. So then moving on, we have our conversions. Now our conversion from pounds to newtons is 4.44822 times your weight, because 1 pound is 4.44822 newtons. Similarly, our conversion from pounds to kilograms is pounds times 0.454, because 1 pound is 0.454 kilograms. So let's go on to our actual equations, and first we'll do the equations for the elevator going upward. Now, Nick's initial weight, which was 178 pounds. His final weight, or his weight once he hit constant velocity after acceleration, was 209 pounds. So when we punch it into our conversion to get newtons, we find that his weight in newtons is 791.78316. His then final weight in newtons with constant velocity was 209 times 4.44822, which is 929.67798 newtons. And to find his mass, we do 178 times our conversion of 0.454 to find that his mass at all times is 80.812 kilograms, that being constant. So then moving down, we have our force final minus force initial equals mass times acceleration, meaning 929.67798 minus 791.78316 equals 80.812 times acceleration. So when we get our final number, that's 137.89482 is the difference. Divide that on both sides by 80.812, which is the mass, and we find that our acceleration is 1.70636564 meters per second squared in the elevator at Jerry's. Now we will find the acceleration of the elevator going downward. And again, Nick's initial weight is 178 pounds. He did not add any weight between our filming. And his final weight, or essentially his weight when it became a constant velocity downward, is 168 pounds. So to find the newtons of the weight, it's 178 times 4.448, which ends up at 791.78 again, and then 168 times 4.44822 equals 747.30096 newtons as which would then be his weight in constant. So then looking down, we again have the same mass of 80.812 kilograms. So we'll punch that all into the equation. We find that his final weight in newtons of 747.3 minus his initial weight of 791.78 equals 80.812, his mass times acceleration. We will then run the equation and find that negative 44.4822 equals 80.812 times acceleration. Divide out 80.812 on both sides, and we find that the acceleration downward of the Jerry's elevator is negative 0.55044.053 meters per second squared.
Conclusion, our hypotheses were right. When the elevator was going upward, we predicted that my weight would go up and there'd be a positive acceleration, which there was. My weight went from 178 to 209, and the acceleration was 1.706. And when the elevator was going downward, we predicted that my weight would go down and it would be a negative acceleration, which it was. My weight went from 178 to 168, and the acceleration was negative 0.55044. Okay.